Hi, my dear. Uncle Demi. Here I am. How are you? My dear, irrigation efficiency is our sixth subject. It indicates how efficiently the water supply is used, based on different evaluation methods, design of the irrigation system, preparation of land, skills and accuracy of the water users and the planters are the essential principal factors influence the irrigation efficiency. Flushing of water through irrigation occurs during the conveyance, distribution, deep percolation, runoff, and also by evaporation process as a case of applying sprinkler irrigation method. In addition, efficiency is influenced by cleverness and cost of labor, types of planted crops, soil characteristics, and culture of human people. Water conveyance efficiency. Losses of irrigation water which occur during conveyance it from its different delivery sources such as streams, reservoirs, and or water wells, either tube or open, are often excessive at most of cases and under all conditions. Accordingly, measuring and calculation can be carried out through the district network by applying water conveyance efficiency formula as shown in the enclosed equation. Table showing the indicative values of the conveyance efficiency percent for adequately maintained earthing and lighting irrigation channels. My dear, look and show the comparison. Water application efficiency. Normally, application more water to the soil than its holding capacity to the desired depth of crop root distribution zone, causing a deep percolation under this critical depth. In addition to occurring runoff at the lower end at both spark and border straight irrigation method cases. Accordingly, water application was developed to measure the efficiency of which water delivered in the irrigated plot was really stored within the crop root zone in the soil, where it can be used by plants, as shown in the enclosed equation. Accordingly, water application efficiency, which is less than 100%, means occurring water losses by NY. However, under the actual irrigation practice, water application efficiency under gravity irrigation method is generally in the range of 6%, whereas it is around 75 and 9% under sprinkler and micro irrigation methods respectively. Different ways of losing water during its application to the farm can be represented, such as surface runoff from the irrigated plot and or deep percolation below the root distribution zone. Hence, follow up the enclosed equation. Table showing the application efficiency under different irrigation methods. Look, my dear, by yourself under gravity irrigation and sprinkler irrigation methods. The rest of previous schedule. Look, my dear, to the application efficiency under different systems of micro irrigation methods. Anyway, there are many factors contributing water losing and so effect on the application efficiency in the farm, such as land leveling, irrigation method, size of irrigation tree, length of run, soil characteristics, depth of applied water, and skills of planter. Water use efficiency. The proportion of the beneficial use of water from the delivery amount to the plot is known as water use efficiency, and so can be calculated as shown in the enclosed equation. Moreover, water storage or substitution efficiency, as sometimes low efficiency occurs not because of applying excessive water, but because of insufficient storage quantity in the root distribution zone in the soil. Accordingly, to evaluate and solve this problem, the concept of water storage or substitution efficiency is an important and useful item. This concept attention directly to how much the additional water to the field has been completely covering the water requirements in the crop root zone during the irrigation period, as shown in the enclosed equation. Water distribution efficiency. An important characteristic of applying irrigation water to the field is the uniformity of its distribution through the root distribution zone along the field. Good distribution uniformity means obtaining homogeneous on-plant growth along the field, while non-uniform distribution causing and appearing an obvious drought spot, which normally tend to the accumulation of soils and reflect negatively on the yield, as shown in the enclosed equation. Uniformity coefficient is an expression developed by Christensen and known as Christensen coefficient, as shown in the enclosed equation. Look, my dear, it is a solution of the getting example before, showing the deviation percentage between the two plots. Consumptive use efficiency, and sometimes water was stored in the root zone during the irrigation time, not completely remaining in the soil for using by plants, lefting a wide spaces between the plant rows and plant itself on the rows will result more exposed area and will assist also for losing more water by evaporation. Accordingly, applying more density of planting and good irrigation practice will assist to increase the consumptive efficiency, which we evaluate by the enclosed equation. Project efficiency. This concept indicates the effective use of irrigation water diverted from the source up to it actually stored in the soil zone in the project area. It represents a clear guide of all the occurring losses through the conveyance, seepage, deprecation, runoff in the project area. For evaluating the project efficiency, you can follow the enclosed equation. Operational efficiency is a guide and judgment upon the effectiveness of management design of any irrigation project, as shown in the enclosed equation. Moreover, economic irrigation efficiency is a net guide upon the overall efficiency of the project because it relates to the final input to output, as the net income is the logically main purpose of any project, as shown in the enclosed equation. Some indicators of irrigation practice. There are some theoretical indicators related to conveyance, application, and distribution of irrigation water, which have a rule on successful and assisting the water user association for achievement of good water management, and consequently a real development in the agricultural field, such as adequacy. Expression indicates the adequacy of the actual discharge of water diverted from the main channel of project to cover all the different water requirements of crops in the overall area. This indicator is calculated and confirmed by the compiler to be a practical and numerical guide parameter as shown in the enclosed equation. Parameters of adequacy expression. Moreover, there are two another indicators of irrigation practice, such as dependability, which is the ability of obtaining the irrigation water requirements by the adequate quantities at a suitable time, which depends on the available water resources, irrigation structure, and available energy resources. Moreover, equity also is meaning an achievement of equivalent distribution of water to all the water user association in the project plot without any consideration for the definition of human necessity, location, culture, and or situations. Many motor patterns under different treatments of water application under 3 different treatments is shown in the enclosed figure. Follow it by yourself, my dear, it is so easy. Generally, efficiency of 100% are not always desirable. Maximum net profit can be obtained by filling the crop root distribution zone only every second cell or forced irrigation depending upon the soil characteristic and type of crop. This is normal because of the ability of plants for consumption more water from the upper portion of the root distribution zone than the lower one. In addition, that alternating the changing of water application depths promoting better growth and more activities of soil microorganisms. Thus, a water storage efficiency of less than 100% periodically may be producing best results and homogeneous on plant growth approximately as shown in the illustrated figure. Figure showing common properties of moisture patterns under different irrigation practices. Look, my dear, these achievements which are described before. An example on how you can calculate the different irrigation efficiency, such as water conveyance efficiency and water application efficiency. Follow it, my dear, by yourself. It is so easy. Calculation of storage efficiency. Follow it, my dear, by yourself. It is so easy. The rest of calculation, the irrigation efficiency and water distribution efficiency. Follow it, my dear, by yourself. It is so clear. An important reference for our subject. Look by yourself. Additional reference, my dear. More and more references. More reference, my dear. Goodbye.